Okay, now, okay, grade 9. So now we are going to solve this problem from your book, from the Brilliant Physics book. Problem 2, page 135. Okay, so this is problem 2, page 135. Okay, so this is the page 135. Okay, the tension in the spring balance. So this is a spring balance, okay, at the end of the spring. Um, Okay, at the end of this spring, there is an object M, okay, which is attached to it. They gave us the scale, 1 centimeter represents 20 Newton, and the gravitational acceleration or field is 10 Newton per kilogram. This means that the object is on Earth. So determine the magnitude of the tension in the spring. Okay. Here, to be able to determine the value of the tension force, it is the tension force is represented here by this vector. So all you have to do is to measure the length of this vector, and the length is 2.5 centimeter. Um, okay, I don't think it's 2.5. ما بعرف صراحة مش مبين كأنه 2.5. But I don't have a ruler, so you have to measure it. Let's say it's 2.5 centimeter. So, okay, how do you find the magnitude? You know that the scale is 1 centimeter is 20 Newton. We place the centimeter under centimeter, so the length, which is 2.5 centimeter, we place it under the 1. And we want to find the magnitude of the tension force, so we need to find T. And we now cross multiply, or you can directly do tension is equal to 2.5 times 20. Okay? Uh, so the tension is 50 Newton. Okay? Okay. Tension is equal to 50 Newton. Now list the forces acting on the block M. Okay, what are the forces that are acting on block M? First, we already mentioned that the tension force, okay, is acting on block M because it is being attached to the spring, so the spring is holding it and it is exerting a force, which is the tension force. So we have the tension force, tension. Let me give you the symbol for the tension force. And also we have the weight because it's on Earth, so it experiences a gravitational force, okay? So the weight W. Now write the condition of equilibrium. Okay, now we need to state this condition of equilibrium. Since the body S is, or sorry, since the body M is at equilibrium or at rest, then it is at equilibrium, which means that the forces acting on this body, okay, they are equal in magnitude but opposite in direction. They have the same line of action, which is in this case vertical. So let's start stating this condition. Okay, so we need to write according to the state of equilibrium. Okay. Okay, we know that the two forces acting on the body are the weight plus the tension. These two forces, they cancel each other because the body is at rest. Okay, so they have opposite direction. Okay, so one is pointing upwards. إذا بتلاحظوا التنشن it is it is taking it or it is pulling it upwards. However, the weight is pulling it downwards. عم يشد فينا نزول. So they have different directions. That's why we have a negative sign. But the magnitudes are the same. So W is equal to T, which is equal to 50 Newton. Okay. Okay, قالولنا number 4, deduce the magnitude of the weight. We already did that. So W equal T equal 50 Newton. And then the mass. How do I deduce the mass? The mass, as we said, I will remind you with the triangle here. W هي mass times G. So the mass, if you want to find the mass, you cover the M. So the mass هي W over G. Okay, so 50 divided by 10 هي 5 kilograms. So the mass of the body M is 5 kilograms. Characteristics of the weight, in all cases, they are the same. Point of application دايما بتكون a center of gravity. Okay, خليني أغير شوي بس. Let me write it here. So 5. point of application دايما center of gravity يعني center تبع ال object. Okay, where the two diagonals intersect. The point of application يعني where the force is being applied. دايما for forces acting at a distance مثل ال weight مثل magnetic force مثل ال electric force دايما بتكون ال point of application هي ال center of gravity of the body. Line of action, this is the second characteristics. كيف ال weight دايما هو vertical لأنه everything falls vertically downwards. Okay, so دايما vertical weight, ال direction downwards. Okay, downwards. Magnitude يعني the value of the force W equal to 15 Newton. Okay, these are the characteristics for the weight vector. Now represent the forces acting on on the same diagram. Okay, so since they have يعني التنشن أساسا it is represented, it is already represented, okay, from the point of application of the يعني point of contact between the spring and the body. Along دايما ال tension force بيكون along the spring or the rope. Okay, يعني vertical as in here. ودايما حد الفورس معنا نحط السيمبل of the force وكيف how is it pulling it دايما السبرينج يعني عم بيهديها so دايما عم بيهديها لو ما السبرينج it will يعني the object will fall downwards so هو عم يشقلها يعني so the force will be pointing upwards. الويت كمان إذا بنستخدم same scale كمان رح تكون عندها same length as the tension force. It starts from okay دايما لتعملوا representation for the forces follow the characteristics يعني مثلا point of application هي center of gravity يعني ال force must start from the center of gravity. كيف بده يكون ال line of action vertical like this. كيف ال direction downward يعني the arrow must point downwards. okay أكيد ال length رح يكون قد ال length تبع tension force because they have the same magnitude. So this is the weight. Okay, these we will stop at 6, okay? Because 7 and 8 we still haven't covered the principle of interaction. This is for another time, okay? Have a nice or have a good night, okay?